Hi, everyone. Welcome here to the California Academy of Sciences this Wednesday, the 18th, I believe, here of January 2023. And we'll be taking another tour of the universe as we've been doing for the last few Wednesdays here now. And I'd just like to thank everyone who's joining us today. Feel free to just in the chat during this tour that we're taking you on, if you've got any questions, if you want to just say hi and say where you're from, we'd love to hear that, kind of get an idea, because I think we've got viewers from all over the world. I know folks in the UK, of course, here in America, we've got some local viewers, but anywhere you are, feel free just to let us know. We're always glad to get an idea where people are watching from. But thank you for showing up. And today we'll be taking you on a tour of the universe, starting, of course, from our home here at Earth. But to start off, before we kind of dive into things, I just want to say the program that we're using, in case you're curious, is a little application called OpenSpace. OpenSpace is one that you can get on your own, too, if you end up watching this and deciding you want to take your own tour or kind of explore the universe in your own leisure. You can download OpenSpace from OpenSpaceProject.com. So if you search that up, give it a Google search as well if you need it. You can end up finding the system specs and where to download that. So feel free to, take it for a ride yourself if you've got the machine to do it, and see what kind of fun you can have. So, like I said, though, we'll be starting above Earth here at the International Space Station. This beautiful piece of technology here is sitting up 400 kilometers above Earth's surface. Now, if you're thinking about it, that's really not too far in the grand scheme of things. If you could go straight up, really wouldn't take you that long to get this high out. But obviously, that's something that's a bit more difficult to do than just taking a quick drive across the country or anything like that. So 400 kilometers up is where we're able to anchor this fella here and have it kind of going around our atmosphere. And it's really as far as we kind of go in the current day as human beings. Multiple countries, we have people who go up and will reside inside of the International Space Station here for periods of time. And that's really, in terms of space travel, as much as we really do nowadays. The ISS is the largest thing that we have ever built in space. Nothing else can really compare to how big this is here. In fact, if you were including the panels on the sides, it's about as long as a football field, an American football field, if you're familiar with that. It's so big, in fact, that you can see it with your eyes if it's over you at night. You don't need any sort of technology to assist you in seeing that necessarily. And it's circling pretty quick around the Earth, too. Once every 90 minutes, it'll pass around. So it's going at a nice jaunt there above our beautiful sky. And if you see here, this little yellow trail that's coming out from it, if I zoom out a bit here too, that is a trajectory you can kind of see of the path it's taking around the Earth. And the images we're seeing now of the Earth itself are actually real-time images that OpenSpace feeds in of our planet. So this is actually what it's looking like right now in our home here in space. So that, the ISS right here, obviously that's our starting point. This is our home. But if we start going on a tour of the universe, we're going to go a bit farther out. But let's, not jump to the end immediately. So let's start next best thing here. And we're going to kind of back off from the Earth, show you a bit more. But then we're going to soon find the moon. So let's do that. First things first, we'll just toggle that little orbit off. We don't need to see that anymore. And if we were to try to find the moon here, put a nice little orbit on that so you get an idea of where it is, but we're going to zoom in on that fella now. So getting closer and closer. This right now is Luna, our moon. Now it's a little dark looking at this angle. We can obviously spin around too, but I'm also just going to fiddle with the controls back here, and we can lay it up, make it easy to see. And you can get a nice clear image of that rocky surface with all the little dinks and craters from any space debris that's hit it over all the years it's been around. It's a very cold, lifeless hunk of rock, but still beautiful, still one we appreciate. And as you can see, it's taking a lot of hits in certain areas. But still, just a beautiful thing to look up in the sky and see every night. So the moon is the furthest that humans have ever been in space. The ISS is the furthest we've kind of been nowadays, but the moon is farthest we went back in the 60s and 70s. This is about 400,000 kilometers away. So, a lot more than just the space station at 400. And it's got no atmosphere, no gases like the Earth does there to keep something from, especially those little meteorites that hit it, from doing so. And distance of, in terms of travel, to kind of help you get an idea of how far it is from the Earth there to here, it's about 300,000 kilometers a second, so about 1.3 seconds traveling at light speed, which light speed is kind of how we have to start measuring things when we get out this far, because we're just at the moon at this point. We're not even deeper into space, and we're already talking really big distances. So how we like to discuss the distance and travel is that light speed, things moving at light as fast as we can go. But this is just our moon sitting outside of our Earth. If we want to back up even more, we can start seeing the other players in the solar system as well. And I'll make sure I turn on some trails as well here so we can see those as we back up and do a little spin as well. Focus on our sun, since it's the center of our solar system. But starting off, we are, of course, the third planet from the sun. Number one being Mercury right here, followed by Venus, and then there's us. And then Mars after that. And we're the first kind of four here in this main section. In between all of that, we have a lot of floating debris. The asteroid belt is what you may have heard of. And that's just sitting all kind of between here. And that's acting as a little barrier until we get to our next set of planets here, as we continue to scroll out further. Past that, we have the much larger four of Jupiter sitting at number 5, Saturn after that, Uranus, and then finally ending in Neptune. Now, we still want to give a shout out to Pluto, small little dwarf planet that we used to include in that list, who may not be there anymore, but still in our hearts, So always like to just tell Pluto that I'm thinking of it. And if we toggle the trail for that, you can see Pluto right over there still, just hanging out all the way deep back there, pretty far out. And then also, along with Pluto, if I show something else here for you, we can get a nice view of these little yellow lines. Now, those yellow lines are various spacecraft that we've sent out, Voyager, Pioneers, New Horizons, that we've sent out to deep into space, and their distance and kind of trajectory so far. So you get an idea of some of the farthest things that we've sent out. Some of them have gone quite a bit compared to the rest of the planets in the solar system, but as you're going to see in a moment, there's still plenty further for us to go. So that said, we're going to keep going out further and further. I'll even take us back a bit here more. And then that sun that's so big and lights up our sky just starts to become a little dot. A dot not much more discernible than some of the other ones that you can see. And then that dot specifically is the center of one more thing, though. Something I'll show you right here. This big blue grid that I just turned on that you can kind of see going outwards is something that is called the radiosphere. Now, this radiosphere is essentially how far, it's not the same as a piece of equipment we send out, but these is kind of the edge of a radio signals that have kind of emanated from our planet. The Earth actually being the center of where that's all coming from, I should say. But the radiosphere itself, signals that we've sent out from our human activities, this is as far as it's gone out. So anything that is inside that radiosphere, that if it had the capacity to pick up those signals, would actually know that we're the ones sending it, if it could read that. And so we started sending out radio signals from our planet for about 100 years ago, and we continue to do so today. So this sphere is always going to be expanding as that travels out at the speed of light, those signals there. One other thing we can see here, if I hit this button, all these little blue dots around that big radio sphere and inside of it are a little something called exoplanets, which are planets and stars, or planets that are around stars, very similar to ours in terms of just, I guess not very similar to ours, but they have the capacity to potentially be places where we want to look and see what's there, what those planets might be holding, because they could potentially have life. And these are just some of the exoplanets that we have read. There's more around there that we have not even found yet. And so this is just kind of what we know about so far. And we are even tracking, I believe NASA themselves has a tracker of the exoplanets that we discover and continue to discover. So if you're ever curious on what we found so far or how much we keep finding, you can always keep track of that as well. And so these circles are just all stars with at least one of those exoplanets sitting around in there. And if they happen to house anybody or have anybody who could read those radio signals that have leaked out from our planet, they might know that we're there. But this is the farthest influence that humanity has so far in the galaxy. It may not be, like I said, something that we've directly put out there, but in terms of our footprint, knowing that we're here, this is as far as it goes from our planet. And it's still, a pretty small amount of space in the grand scheme of things, because we're going to pull out even further. So let's turn that off. Let's turn those off and keep backing up, because away from just our solar system and our set of planets that we're familiar with, we are sitting inside our galaxy, the Milky Way. And now the Milky Way is this very pretty flat disk right here. We're right at some of the kind of on towards the edge of one of the arms there. We're not towards the center. But the Milky Way is our galaxy, this big flat spiral. And we're not the only one nearby. The closest other galaxy is actually the Andromeda galaxy. That one's fairly close to us. But that's, I say fairly close, but that is still 2.5 million light years away. So if you were traveling at the speed of light, it would still take you 2.5 million years to even get there. Basically what we're seeing when we do look at the Andromeda galaxy is what it looked like 2.5 million years ago, because that's how long it takes for the light that we're looking at to even get to us. So, we can call that our closest neighbor, but it's still pretty far out there for what me and you were concerned about. And pretty much, every other dot you see in the background here, now that we've zoomed out this far, is another galaxy that we've detected based on surveys that we've taken. So even farther out than that 2.5 million light years, we've got way more planets and galaxies housing them that we still, are just floating around us. And so pulling out even a bit more, seeing those little dots for galaxies grow in number and size, we will continue to pull out faster and faster. And you'll see a shape start taking form here, kind of an interesting one. Maybe you have seen it before, but if not, you may not guess. It is this beautiful little kind of almost butterfly wing, or I like to think of it as two cones, or like two drills or something touching, something like that. But this shape, like I said, all these dots are just other galaxies. And you might be wondering, well, what's with the kind of shape there? Why do we have all this empty space between? Is this how things are? Is this just how it looks? Well, no, it's because the empty space is kind of just explained by the fact that we can't really measure and read what's in this area because of how the Milky Way galaxy is set up. We're kind of blocking ourselves from reading this area too well. So the cones that you see are pretty much just what we can actually read from our spot, but there's very much likely lots of other stuff here in this gap. And as we find ways to measure that, we'll fill that in as time goes on. But for now, this is the kind of shape that we're seeing. But these are, like I said, all other galaxies, and these are starting to get to not just millions of light years away, but billions of light years away. It would take you billions of years traveling at the speed of light to reach some of these here at the edge. So, you'd have to buckle in. I hope you have a nice in-flight movie or two or a lot, and enjoy your trip if you're traveling out to the distant reaches of space. But we're not even at the edge yet. So as we continue to back up further and further, you're going to start seeing some of these orange dots as well mixed in. And these are quasars, which are very energetic galaxies, but past even the quasars that are dotting the very edge of this little model we have here, you're going to see this bright orange background. And that is the cosmic microwave background there. This is pretty much just the edge of the recordable universe for us, the observable universe for us. Basically, light was all kind of bound up together when the Big Bang happened. It started to expand out, and this is as far as it's gotten, essentially. And this is as far as we can measure and read. This is what we can see with instruments in our tools, and it's really the farthest we can detect because of that light. And like I said, this is billions and billions of light years out there, so we are very far from home if you wanted to reach the edge of the universe that we can even record. And so it's very humbling when you think about it, just how far out that even is and how much there could possibly be within all of that. Truly is kind of a magnificent, mind-blowing thing. You really just try to sit down and think about it all. But now that we've kind of went all the way out here and reached the edge of the universe, well, there's really nothing much to do but just go back home. So why not just zoom back in? We're going to say goodbye to the cosmic microwave background there and back towards this beautiful little butterfly of galaxies that we've recorded. Zooming in here at a breakneck pace, past these other smaller dots for all those other galaxies that we know are there, and saying hello soon to our lovely Milky Way. Oh, there it is. Still love how that looks. Absolutely beautiful. And then coming in further, we're going to start soon seeing our solar system once more with our sun and 8 planets around it. There's that light shining in. And there we are. And then let's make sure when we're coming home, we're focusing on the Earth. And so now that we have reached the end of our tour, we land right back above that beautiful blue ball floating in space and home where we belong. And that has been just a journey that is really hard to just sit down and comprehend. But yeah, when you think about how big our world seems, you can kind of realize that there's a lot more out there. Excuse the void. That's not what it actually looks like. Like I said earlier, this takes in real time data. Sometimes it doesn't load in exactly how you want. So we'll just we'll look at Australia here. Australia looks pretty good. But now that we're back home, I just want to say thank you all for taking the tour with us today of the universe, coming back home here. And I appreciate everyone coming around. And if you have any questions, hopefully we answer them. And if there's anything you can think of, feel free to post. We've got a lot of links in the chat for you as well, for you to get more information if it all entices you. But thank you very much, and have a great day.